Okay, so this lesson is section 6.1. We're going to be looking at polygon angle sum theorems. So first off, we're going to talk about what is a polygon. So by definition, a polygon is a closed figure formed by three or more segments. Each segment intersects exactly two other segments at their endpoints, and no two segments with common endpoints are collinear. So there's two types of polygons we're going to be looking at. Here's some names for those. Convex polygon is a polygon where no diagonal contains points outside the polygon. So a diagonal is from one vertex to a non-adjacent vertex. So this would not be a diagonal, that would be a side. So every segment joining vertices, non-adjacent vertices. So you can see if I draw any diagonal here, I am not going to be outside of that shape. Whereas here, if I draw a segment between this vertex and that vertex, you can see that that segment is outside the figure. So this would be concave, otherwise known as not convex. And this is a convex polygon. Okay. We need that definition so that we can answer some of the theorems and definitions that come up with what they do. And so the first thing we're going to look at is this right here, the sum of all the angles of a convex polygon. How does the side number in a convex polygon relate to the sum of the measures of the interior angles? So we know from before that the sum of the three angles in a triangle is 180 degrees. So what if I have a four-sided shape? What is all the angles of this four-sided shape going to be? Well, we can do this by simply breaking these shapes up into triangles. Since I know the sum of a triangle is 180 degrees, then this right here, if I draw a diagonal, breaks it into two triangles. So this triangle has a sum of 180. This triangle has a sum of 180. And so together, you add those together, and the sums must be two of those. And the same thing here. This five-sided shape can be broken up into three triangles. The six-sided shape can be broken up into four triangles. And if I do this, a pattern emerges. And that pattern is that I can find out the sum of all the angles because I'm going to get two less triangles than the number of sides I have. So if I have a five-sided shape, I'm going to get three triangles. A six-sided is four. A seven is five. So an n-sided shape is always going to be n minus two triangles. And since each triangle is 180 degrees, I simply need to multiply those two things together. And that gives me the sum of all the angles in the interior of a convex polygon. And so here's our little theorem right here. So the sum of the interior angles of a convex n-gon, n being whatever number of sides I want, is 180 times n minus 2. Okay? So that's good to know. The next definition down here is what is a regular polygon? You're going to see this term a lot, regular polygon. A regular polygon is a polygon where all interior angles and all the sides are congruent. Okay, so an examples of regular polygons would be the equilateral triangle, the square, okay, and then for four sides, the square would be the regular polygon. For five sides, it would be something that looks like that, but all the angles have to be exactly the same. Okay, the hexagon. Okay, this one right here for 7, all the sides are the same length, all the angles are the same, and so that is what a regular polygon is. If I know a regular polygon, then I can talk about the measure of one of those angles. If all the angles of the polygon are equal, then I can use the sum and determine what each individual angle is actually supposed to be. So here's a regular five-sided shape. This is called a pentagon. If I want to know what one angle measurement is, then I simply find the sum of all the angles and then divide by 5. So that's how this formula is generated. So here's an example. Let's go ahead and do one. So our question is, what is the interior angle sum of a 17 gon? So a polygon with 17 sides. So how would I go about doing that? Well, since it's regular, I think I forgot to put regular in there. No, just the sum of the 17 gone. So we're doing the sum. So that means I'm going to have to figure out what? Well, it's going to be, our formula is 180. It's 180 times the number of sides minus 2. Okay, we multiply this out, so this is going to be 180 times 15. And if you do this on a calculator, you're going to get the sum of all the angles to be 2,700 degrees. Okay, so if I add up all the angles of the 17 gone, that's what the sum is going to be. Okay, the next question I can ask will be similar to the regular one. So here, each angle of a regular n-gon measures that, 172.8 degrees. How many sides does this have? Okay, so our formula basically was saying that the interior angle is 180 degrees times n minus 2 divided by n. This is how I find this, the interior angle of a regular n-gon, and I want that to be 172.8. So this gives me this equation that I can then solve for n. Remember how we did this? We just cross multiplied. This is a fraction. Cross multiply 2.8 times n. So do your distributing and all that stuff. This here is 180 n, 360. And then start solving this out, bringing this over here, bring that over there, and you end up with 7.2 n is 360. And then I can divide by 7.2, and I'm going to get 50 sides. So a 50-sided regular polygon will have that measurement as an interior angle. Okay? So the next question we have, or next definition we have, is this thing called an exterior angle of a polygon. An exterior angle of a polygon is basically just extend a side of a polygon, and that angle that is formed right there. Okay, so think about when we did exterior angles of a triangle. We're just going to do it now for a polygon. They don't all necessarily have to go in the same direction, but this one just illustrates them all going in the same pinwheel action like this. So these are all exterior angles. You just extend the side of one side, and then the angle formed by the adjacent side in that extension is an exterior angle. So what do I know? No matter how many sides it has, if I add up all the exterior angles for all the sides of the polygon, it's going to be 360 degrees. And stop to think about why that would be. Because what I'm doing, if I start right here, okay, and I walk here, and then I turn, and walk to here, and then I turn, and I walk to here, and then turn, and then turn, and then turn, basically all I've done is I've just gone around in one big circle. So that's why it's 360 degrees. So if you think of it that way, it's pretty obvious that, yeah, it's going to be 360 degrees because you're just going around in a circle. And 360 degrees is the angles of a circle. So let's take this then to the next question, and let's try and do an example. So here's an example that we have right here. Okay. So I have this shape over here, 1, 2, 3, 4, 5, 6. And then I tell you this information over here. So 1, 3, 4, and 6 are all congruent. 2 and 5 are congruent. This angle right here is this angle plus 30. So I want to know what angle 4 is. And there's a lot of ways to do this one. So here's what I did to kind of show you how everything works, is I made connections between everything. And I just changed all of these. If you look closely, all of these are the exterior angles of this shape. There's 1, 2, 3, 4, 5, 6 sides to this polygon, and this is an exterior angle for this extension and that side. This is the exterior angle for this extension and that side, and so forth and so on. And so all of these, see, I remember I told you they don't all have to go in the same direction, but all of these are the 6 exterior angles. So I know that all of them add up to equal 360 degrees. So I know that the measure of angle 1 plus the measure of angle 2 plus 3 plus 4 all the way up to 6 must equal 360 degrees. Now, some other things that I know that the measure of angle 5 is the measure of angle 2, which is the measure of angle 3 minus 30. So how do I know this? From this expression right here. Okay? If I take this right here, if 3 equals this plus this, then 2 equals this minus the 30. So I just subtracted it out. Now, why would I want to do all this kind of stuff? Okay? Well, I also know, as I do this kind of thing, that 5, and so both of them equal this. And so what we're going to do is we're going to go through here and work all these things out. I know that angle 3 and 4 are congruent. So from this expression right here, I can change this. As 3 and 4 are equal, then I can change this to the measure of angle 4 minus 30 is those two items right there. So with all these congruencies and stuff, I'm going to replace all of these angles in here with an expression for the measure of angle 4. So 1, 3, and 6 are all congruent to 4. So I can just exchange these all for angle 4s. The measure of angle 2 I can write as that. The measure of angle 4 minus 30. Angle 3 is congruent. So this is just replaced by an angle 4. Angle 4 is still there. Angle 5 is this thing again. Angle 4 minus 30. And then angle 6 is congruent, so I can just replace it with another angle 4. And so what I've done is I've changed all these angles to an angle 4 equivalency. So how many angle 4s do I have in here? I got 1, 2, 3, 4, 5, 6 of them. I have 6 measures times the measure of angle 4s. And then here I have minus 30 and minus 30, so that's minus 60. And then I can just work this out. And so then move the 60 by adding it. So I have 6 times the measure of angle 4 is 420. And so divide by 6, and the measure of angle 4 is 70 degrees. So that is a way to do this problem. Here's another problem down here. A little twist on some things. The measure of each interior angles of a regular 100-gon is that expression. What is the value of x? Okay, so what is the value of x? So it's a regular interior angle of a regular. So we have that formula. Remember, the formula was 180 times n minus 2 divided by n. This produces the measure. This is the measure of each interior angle, right, of a regular n-gon. So then using this concept here and what we did before, let's plug in what we know. So I have 180, 100 minus 2 over 100 must equal this expression. Okay, so this right here is an actual number. You can work this out. Okay, and if you type this all into the calculator and such, what do we end up with here? Take all this stuff right here, you're going to get 180 times 98, 100. You can reduce this out, use a calculator, work this all out, and then you can also subtract this quantity over here. When you do, you're going to end up with 3x equals 150. So work this on the calculator and subtract 26.4. When you have that, you'll end up with this equation right here, which I can then solve for x and get 50. Okay? And so these are kind of the questions you're going to be doing in 6.1, working with the interior and exterior angles of polygon and regular polygons. And we'll do more problems together.